also. So yes, go ahead, start the session.
Yeah. So today's topic is about replication log. Before we go there, let's start with distribution of data. So here we are going to speak about distributed missions, storing data on multiple missions. So do not just rely on single mission because of the growth of volume of data and many other reasons. We go into some direction which is called distribution of data, in which you have a lot of missions working together to solve this problem. So why move to a multiple mission? Scalability. A single mission cannot fit large data. Say that even if single mission can fit large data, but high writes and high reads unable to handle. Availability. One mission goes down, the other takes the load. Latency. When you grow into different geography, you also grow in terms of data centers present in different geography, so that users close to some geography always get the closest center to save the latency. Scalability is achieved through vertical. It is like you're ramping up the CPU, RAMs, or NFS, or through horizontal scaling is like you're sharding VMs, your Dockers. Horizontal scaling is much cheaper when you consider using VMs or Dockers and commodity hardware. So how is data distributed across missions? Two parts. One is your replication and partition. Now,
So
what is
yes,
replication?
Manoj, a few things I would like to just discuss in this.
Yeah,
First is why move to multiple machines. I also see one reason, which is ensuring reliability or redundancy, right?
yeah. I would be
Backup is
coming to that part.
okay.
So as part of replication, right? So availability, redundancy, latency, handling high reads. So I would be explaining them separately. So that's so why
Great.
move on to multiple missions, basically to do a scalability, availability, and latency. Then in the replication part, how do you handle all these? So why replication comes into place? That's I think probably once I go by step, I think all these would be.
Yes, yes. And then coming to scalability, I had few points probably I would like to share. One is for relational databases, generally the data volume is, I would say, from somewhere around 2 GB to 5 GB. So if you are in a situation where you have to store more than 5 GB data, right? So also there is possibility to shard and create multiple shards or partitions of the database, but that has another challenge. But when the data volume increases after 5 GB, then we should also consider using some other technology, NoSQL database, because that is something which is outside the scale of relational database. But here, with multiple machine, you can solve it with sharding and partitioning, right?
Yeah, that's right. So
Correct.
I probably guess I would be covering all that one
Okay,
step.
okay.
Uh,
Perfect, perfect.
I want to go by step so that people
Yes, yes. Go
understand.
ahead then. No, no
Yeah.
problem.
Yeah. So now, so there are two parts to distribution of data, right? So one is replication and partition. So now, what is replication? Is basically the redundancy of same data is present in many machines, which will lead to availability because you have the same data copy on different machines. Even if few of them go down, you can still process or you can serve, can be still access the running replicas, and therefore it can stay available and help you to reduce the uh, latency. So all these, right, with the replication itself, all these comes for your help. So latency replication across all data centers, right, present in different geography. This can help us with users being redirected to the replica. So the network latency is also improved when you're talking about replication. So all these, right, with the help of replication, you can achieve. Replication can handle high reads when you have different replication for write and read DBs. So I think when you do system designs, when you want high availability and there is a high read, you basically have a write DB separately and a replica of that as a read DB, where you can scale horizontally the read DB alone. So that is why you basically go for replication and all. So now what is partition? Partition is extremely important when data is too big to fit into a single machine. So in this technique, we basically create partition of data sets and we store different segments in different machines, and we can have different, I think I have a problem with this. I need to disconnect.
Take your
and
time, no
share
problem.
always.
Yeah, you can just take your time to get your setup back.
Give me a minute. Yeah, so we store different segments in different machines, and we can have different algorithms which help us to do this. Like you have consistent hashing, you have range-based partitioning, then you have entity-based partitioning, then you have geo-based shardings. All these can be achieved through partitioning when you have, even after replicating, right, data. Even if that replication within the read DB or the replication DB has a huge data, then there will be a lot of latency if you do not partition. So that also helps. You need to partition data within the each DBs so that it improves your latency. So any questions there? So how do we solve replication sync problems? Okay, now let's consider this diagram, right? Let's say that if there is a balance of 500 and we are writing a new balance as 100, right, into this particular mission, to this particular mission, it might happen that the other user reads the balance from this mission. So there is another read which is coming to this mission, that read mission, the mission 2. At this point of time, it is conflicting whether the balance should be 500 or 100. There might be some lag between the sync or replication which happened between these two systems. So in which you might write the new balance as 100, but during the time in which the sync is performed, the read on this mission will read as 500. So as you can see, this replication, it is very easy in an interview to say we can do replication. So basically is that, so what happens is when there is a replication problem, right, between these, a user writing to the one of the mission 1 as 100, but at the same time there is a user who is reading 500 from the mission 2. So there is always a replication lag problems and all. So how do we solve these? All these we would be speaking in the later session, but this is something that there is an issue with the replication. It's not so easy to implement replications. So that's what I want to highlight here. So we can tell that we can do a lot of reads and writes separately. So that's as I told in the previous page, that we can do heavy reads separately and heavy writes separately by doing replication. But how do we solve all these conflicting problems? There are 3 different ways to solve this problem, or you can call this as an architecture. Like single leader, you have multi-leader and leaderless. So in a single leader architecture, right, looks like something like this. This you can have a mission which is which is made as a leader, there can be a lot of followers which maintains a sync with the leader, and the leader is responsible for handling all the writes, whereas the reader can be done from the follower as well as the leader. Now, this sync algorithm can be performed in two ways. One is you can do it through asynchronously or through synchronization. So asynchronous processing, right? So in an asynchronous replication, the user performs a write on the leader and gets a response back only when all the followers have all the process the write, so that it is very good with the data durability, because all the followers are always in sync, and only when we release the control that we have processed the data, so that is when the complete sync process is completed, and this will basically increase your latency, because the leader waits for all the replicas to be written and then responded back, and then it sends back to the user. But whereas in an asynchronous replication, right, the leader processes the writes and tells the user that your writes have been processed. The replication to the follower is happening in the background, and therefore the asynchronous replication is fast, but obviously there can be a lot of problems. At the same time, synchronous replication has its own downside. We will look into that when we are talking about replication architecture. So both, right, sync and async have their own problems. It's up to us to decide which one you wanted when you're trying to design a system. That's very important to consider all these. So you have advantages and disadvantages in both replication systems, like whether you choose asynchronous or you choose synchronous. Say you are choosing synchronous, then there is a latency issue, because say that you have one leader and there are 10 replication, then all the 10 replication has to respond back. That's when you tell the user that, yeah, I have successfully written it. But when you see that latency is very important for you, then you go with asynchronous process, saying that only the leader takes the write, and then asynchronously in the background it pushes the data to the followers. But see, everything has a trade-off. So when you look for a very high low latency, then there would be stale data. When you look for high latency, then you will have consistency across. So that's how these systems are put in place. So any questions you have here?
Maybe in the leader scenario, leader election is another complexity, right? So
Yeah, so I would be covering all
covering
this.
it going forward. Okay, great.
Yeah, I would be covering each of them. So this is just
Yes,
an high-level topic that
yes.
I'm just
Not
before I go a little
awesome.
deep into that, I'm just telling that these are the
Awesome.
problems that would occur.
Right, right. So for multiple leader architecture, there is another problem which is consensus, right? So these are
Consensus, split brain, all these happen when you have multiple.
correct, correct. Okay,
Yeah, I
okay.
would be covering them
Yes,
as I proceed
yes.
through this. I
And the
think
split brain is what you covered. You said no, one database has 500, one has 100. So that is exactly the split brain problem, right?
yeah, so that's more of a replication, but the split brain is more of when one of the leader goes down and it comes back, and that also think
Okay.
that I am the leader. That is when the split brain happens. It doesn't know who's the leader now. It also takes the right. The other leader who has come up also takes the right. Now, how do you solve that problem? So I probably guess, I think if I go
Yes.
slowly right, then people would be able to understand when I come to
Perfect,
this
perfect.
point.
Yes, yes, no issues.
Yeah, so now what if the replication fails over? So now what if the replication fails? And how do our strategies or algorithm ensure that we are able to handle those replication failures? So what if the leader fails and fails to, how do we strategize to handle those scenarios? There are two possibilities, right? One is your replication, that is your followers failing, and there is one thing is that your leader can also fail. So that's the complexity of building a replication system. So multi-leader, how do you handle conflicts? That's what we spoke just now. So how do you handle multi-leader? So when there are multi-leaders in different data centers, how are you going to handle the conflicts? The writes on same data can be done at various leaders, which are present in different missions. So how are we going to handle those problems? So there are so now there are 4 different ways that replication logs can be done. One is statement based, one is logical row based log, then that is the val, the write head log, and the trigger based. So before I go directly there, I would like to speak about the sync replication. So this synchronous replication is very easy to implement. The benefit is that the latest data is always present in all the replicas, even if the leader goes down. Since all the followers have the latest data, we can make any of them as the new leader, and it is very easy to process the scenarios of the leaders going down. However, the downside of this is even if the follower crashes or there is a network failure or the writes fail on one of the follower, then you cannot process the writes from the user. So the probability of writes succeeding decreases a lot when you're talking about asynchronous replication. So consistency will be hit, but availability is always guaranteed in asynchronous process. Say that your leader goes down, but your system is still available for taking up the reads and things. So in an asynchronous replication, the writes are always fast because you write only to the leader, and then it is replicated to the follower. The writes are generally the replication. So the writes are obviously pretty fast because you are not really waiting for all the followers to proceed. The writes generally, the replication lag may be less than 1 second because the replication is quite fast. However, the downside of the asynchronous replication are a lot. The followers may fall behind the leader by several minutes. You can perform stale reads because it might happen that the write has been processed by the leader, but when the reader is happening from the same follower, it has a stale data. So this is what it has, a stale data. So when a leader crashes, right? When a leader crashes and it is not recoverable, so the data loss may happen because the leader has trashed and it is not recoverable. So for few writes which are not replicated to the follower or even one of the followers, what happens to those writes? You cannot recover them. So that is really bad and it is a data loss. So that's what happens in asynchronous, because suddenly the leader goes down and it has not replicated the data, then you're going to have a stale data in your followers or your replica tables. So that issue is always, so that's what, in a synchronous process, you have a different problem. In a asynchronous problem, you have a different problem. Therefore, your writes may not be that durable.
Welcome
Despite
to
all these
distributed
down effects, asynchronous replication is something which is primarily used, and when you're talking about replication algorithms. So even after all these problems, right, generally systems that are built, right, they go for asynchronous problem because you can increase your so you reduce your latency at a very high level. So that's why many of them prefer asynchronous process. So now let's look at how to add a new follower.
One query here.
Yeah, sure.
So master, the term master and leader or slave and follower, are they same or is there any differences in these?
No, it's the same. It's
Almost the same, yeah.
yeah, almost the same. It's master, leader. I mean, they are all same. Slave, followers, or replicas. All these are same.
Sure. Okay, great.
So how do you how to add a new follower? Say that you have set up your replicas, but you still want to, as the data is growing, you still want to have new followers. So we may need, so because you want to distribute the loads, so that's why you're going to add new followers. So how do we do that? So one way is to stop the writes process and add more followers. Copy the data files from the leader to the new follower. Then you can continue to resume your operation in which the leader is processing the write, and it also sends a replication log to this new follower. But this is bad because you are blocking the write until the new follower resumes. So what is the alternative to this? So that these are the problems when you adding a new follower. So how do I solve that problem? Is there are different alternatives. That's what just going to speak about. So the snapshot is taken from the leader. So the other alternative approach is take a snapshot from the leader without the downtime of the leader. So there are third-party tools which can do that. Then copy the snapshot to the new replica, that is the follower, where you want to set it up. By this time, the leader will be still processing the writes. By the time the data is copied to the replica or the follower, the data will become stale at the follower. So this is a consistency issue. This will be more of an availability. So you basically done the copy of the data, and then before the new follower comes up, there would be some stale data in the follower because the leader has already taken up all the writes, right? So when you want to build a system like more of an availability and you're not worried about a consistency issue, and there's a question popping on how do you solve these problems, and this is how you tell them. So the follower will now ask the leader for the data. So how do I solve that problem also? That is how the follower asks for the data update till now. So from the snapshot, and must be attached with some sequence number. So you need to, so how do I know that, how does the follower know still which I have taken the snapshot of the data, and from where should I request the leader to send me the data? So that's basically how do I solve that problem is by using sequence number for those data. So that basically in Postgres, they use a log sequence number, and MySQL uses log bin number, which would solve that problem. So from then on, right, after getting all that, then the new follower gets a further update from the leader. So that's how it works when you want to add new followers. So any question in this? Okay. So what if the followers go down? Let's look at what really happens when the follower really goes down, and what are the issues it can happen. It is easy to process and can be done in 4 steps. The first thing to do is for each follower maintain a log of data change that it has received from the leader. Now, when the follower goes down and then it comes back up, it still knows that the last transaction that it had processed, then it can ask the leader for all the data update beyond this point, and once it has processed that, it can simply continue to receive further updates like other replicas. So that's actually in the follower side, it's very easy because as I told, right, it goes down, then you bring it up, and then the main part is that you maintain a log of data change that keeps on happening on the replication side. So what data has been replicated, what is still need to be replicated, all this you maintain on the follower. Once the follower is back, it knows that still which point it broke, and then it can process the data, and further it can request from which point it needs all the data from the leader, and it simply starts continue to process as any other replica. But what happens when the leader goes down? That's the complexity happens. That's where the complexity happens, and it is really difficult to handle those scenarios. Like, so need to have algorithm to detect the failure and notify the SRE team that the leader is down. The easy strategy to do that is use an heartbeat mechanism which can talk back and forth. And let's say that you have around 15 seconds for the heartbeat. If the leader does not respond back, or if there is a miss heartbeat constantly, we can say that the leader failed. Now it's time for us to choose a new leader from some replica. So out of the present replica, you can easily choose a replica which has the latest data change received from the leader. In this way, you can reduce the stale data. So the other point is you need to reconfigure the rights to this new leader that you have detected. When the old leader comes back up, it should now understand that it is the follower, and it should recognize the new leader, and it should continue to process the update that it received from the new leader. So that's the complexity that is involved when a leader goes down. The other problem with the leader failover problem, other failover problems are for the leaders are, when you're talking about asynchronous replication, it is prone to data loss, and it decreases the durability. Because let's to talk about the scenario when the leader has some rights which are not replicated to any of the follower, and now the leader is also down. So that's the other issue. So as I told in the asynchronous problem, right? So there, when I was speaking, I told, right, so even if the leader goes down and it is not replicated to the followers, and there is a data loss also there occurring. An asynchronous replication, you choose a new leader. The old leader comes back. So now in asynchronous, the old leader comes back. So what does it do with the right which were not replicated to any other leader? In that particular amount of time, it might happen that you have received a conflict right on the new leader. So an easy way to deal with this to get rid of that rights. So in an asynchronous, that's the only way you can do to get rid of that rights that has happened. So the point is that we understand that there is a data loss when you do an asynchronous replication, and you should keep in mind that in an asynchronous replication, it's more of availability than being more of a consistency. In one instance of GitHub, so this has actually happened in GitHub. So what happened in the GitHub in an asynchronous process, right? And out of date MySQL follower was prompted to the leader. The database used an auto incrementing counter to assign a new primary key to the new follower. But because the new leader counter lagged behind the old leader, that is the follower which came as the leader, right? That was lagging behind the old leader which went down. It reused some of the primary keys that were previously assigned to the old leader. So that is because the old leader did not replicate the data. The new leader was thinking that that was already assigned. It started using, it is an auto increment right now. Say that it was 10 was used, still 10 it was used by the old leader. And the new leader did not know that 10 was the primary key that got used. It should count from 1. 11, it started again using it from somewhere like 8 or 9. So now what happens to that? It resumed some of the primary keys that were previously assigned to the old leader. The primary key were also used in the Redis store. So those primary keys were, they were using a cache system like Redis, and they were also using. So the reuse of the primary key resulted in a conflict between the MySQL and the Redis, which caused some private data to be disclosed to the wrong user. So that's what happens, right? So as I told, right, the leader and the Redis were in sync. They somehow were in sync, but the follower was not in sync. Suddenly, the leader went down, and the follower was prompted to a leader, and that resulted in a conflict. So that's the problem you would face when you start building replication systems. So it's really hard even today. You still face a lot of problems with this replication, and there are still a lot of researches going in this part of the system. So now let me speak about the split brain that we were speaking previously. When world leader writes, when there are two nodes, right, say that one of the world leader also comes back. So one of the say there are two leaders now, right? So one of the world leader went down and it came back, and it believes that it is the leader. So in a split brain, there are two nodes behaving as a leader, and if two of them are processing the writes, obviously data conflicts will occur. So you do not have it. You'll run into those issues because both the leaders are now taking the rights, and now who would be deciding which data should be treated as a source of truth. So that's where the split brain split brain actually occurs. The another problem is how do we understand and how to set the leader timeout, and how do we decide that the leader is actually done? Because in the scenario of huge network spikes, right, and huge loads or network glitch, it might happen that the leader was still up, but it can face a lot of load, and that is why it was not able to respond. So some systems, like for these problems, right, like you have if there's a network glitch, suddenly the system may detect that that leader is down, and you may prompt another leader, another follower to a leader, or some other there was a huge data to a leader, and it was actually busy in writing that, and you have sent an odd bit and it did not respond back, and then you suddenly prompt a follower to a leader. So these are the problems that may occur in a replication system. So in some systems, we have mechanisms to shut down one of the node if two leaders are detected. So you should have a mechanism to detect if there are two leaders are there, and then you bring one of them down. So when you bring them, then you need to again determine which is having the latest copy of the data. Then detecting that also becomes complex. So if this mechanism, so when you build such mechanisms, right, you should be very careful because sometimes you will end up shutting down the two leaders. Then that becomes more complex and more dangerous for very high throughput writes systems and all. So there are major other problems like so there are no easy solution. As I told, there is no easy solution for these problems. For this reason, some operation teams perform failover manually. So they would go, so the SRE teams or the database engineers, right, would look into these systems and they would not do an automatic failover. They would see if there is really a problem to do a manual failover. But apart from these, right, like network failure, unreliable networks, then you have trade-offs around replication like consistency, then you have durability problems, then you have availability and latency. All these, you have to take a trade-off between all these, like whether you want consistency or durability, or whether you want availability and or latency. All these comes into picture. So these are the fundamental problems in a distributed system. So before I jump into the 4 type of replication logs, so this was like the overview of really what happens when you're trying to do replication, and that too in a synchronous asynchronous way. And if you have a single leader, multi-leader, or a leaderless things, these are the problems would occur. So any questions further I jump into the replication log? So how replication log is actually done?
Yeah, Devendra and Sheikh, you have any queries?
Not really related to replication. Is this possible to have peer-to-peer connection like master to master or something like that and still have it replicated?
No, you can have that sort, right? You can have that sort is called multi-master, but you still have all these problems, right? You'll have peer-to-peer. So who is the master in this? If you have two masters, then are the two masters going to take rights, or it is only one who's going to take a right? Then if only one is going to take the right, then that is the master. Then you sync it up with the other master. You mean the replica? It's basically a replication of follower of that master. So you need to think that what you're going to do. So are two masters going to take the rights? If they are going to take the rights, how are those going to each other talk and sync the data? Because only one right can go to one. Say that a user writes a data, then it can go to any one of the master, right? How are you going to going to solve that? Again, a replication to the other master. So all these.
Yes, that's true.
Yeah, so that's the problem. That's the problem with the multi master. So that you need to handle all these if you want. So that's where I told you, right? You need to take a trade-off. So
Got it. Okay, thank you.
Yeah.
So Manoj, I have one query.
Yeah.
If we want to try out these setups in our local systems, running two Postgres instances or MySQL, can we do that, and how to do that? Any idea on that?
1 minute. No, you can do that, but probably you need to have different ports, right, configured, and then you need to determine which is your master and which is your slave, and then do a replication to them. Yeah, that can be done. But the point is that in a real world, so that is within a single mission, right? So you would not be really able to run into the real distributed system problems, right? Because it's within the same system, and the data is obviously going to be replicated extremely fast.
Yeah.
When you do it in your local, it's going to extremely. But when you have two laptops, and then you try doing all that things,
Yes.
right? And then you disconnect. When you do a network partition, what really happens, and you try reading it from there, then you'll really understand all these replication problems.
Yeah, I can use two virtual machines and remotely distributed, maybe, right? Use
Yeah.
some cloud environment and get some VMs and try to create these problems, right?
Yeah, but these problems are there. Yeah, I think that's why I told, right, the GitHub had that issue. If you search in the internet, right, saying that GitHub problem, this would come up.
Okay.
So that's more that in that, right? So you see, right, the master and the Redis, I think that's the cache system were in sync, but where the follower, when it was a leaderless, they were following a leaderless. Once
Yes.
the leader went down, they brought some of the follower up, and that follower was not in sync with the leader, and it started using the primary key that were actually used by the leader. So then that would lead to a conflict between the data, right, which were
Yes.
already assigned to a different data for the
Yes.
primary key, which was already used by the leader. Yeah, these are some scenarios which has happened, and yeah, you can get the sense of that, right?
Yes.
These are real problems in the real world scenarios itself.
Right. Then other question I had is, what is the difference between a master and slave? Is this determined by the database configuration, or is it just the application knows that this is my master, this is my slave? Where is this information actually stored, where these instances are master, these
Yeah.
instances?
So basically, these are all more of a configuration based in the database.
Okay.
So you create clusters, then you start configuring. So it's basically nothing but you install the same instance of, say, that MySQL you're installing. You tell you install the MySQL, then you configure that these are the different. Then you install the same MySQL in different servers, and you tell that this is the port that you need to replicate from the master. Basically, right? That information should be part of the master. The other point is that in a leaderless protocol, right, everybody should have that same configuration copy, and there should be like some like zookeeper who keeps track of all these information and propagates that information across to all these followers, saying that, oh, now this is the leader, but this is the now this, once the follower becomes the leader, now we have to tell that, okay, now you need to publish all the data to all these ports so that they take up the data. Yeah, it's actually easy to tell, but when you really start implementing all those, when you start writing code, right, it becomes very complex. You need to have a very good design to put in that place. Yeah, so that's what I told. A single leader is very easy to implement. So any developer can develop that. That's because you know that this is the leader, and you tell in the configuration itself, you will tell, okay, this is the port where I need to publish the data. You give that all the URLs and information that you need to publish it to all these followers. But once you go multi-leader or leaderless protocols, right, then that's where it becomes tricky in writing code itself, because you should be, the system should be designed in such a way that it is auto recoverable. And then the other thing is, it should, the election algorithms are used there to do which one should. So the other point is we need to have to make sure that which follower has the latest data that should become the lead, so that it can publish those latest data to other replicas. So all these complexities starts coming once you start designing all these systems.
Right. Yes. And then I also understand that there would be different kinds of replications, right?
So you have synchronous, asynchronous. These are the two ways of replicating it. But so that these are the two. At a high level, you do synchronous or asynchronous. But how things logs are written.
How part,
Yeah, that is something that I would be speaking about it in these diagrams.
Great. Okay, go ahead.
Let me continue on that. So there are four types of replication logs, which I already spoke, right? So which, so it is statement based and logical row based. And write ahead log and triggers.
Right.
Yeah, so this is the diagram for that. For a statement based. So for insert, update, delete statement, statements are sent to the followers through the transaction log. So you send the all these insert statement into a transaction log, and then you do a direct replication of it. So that's one thing. So the problem with this is that, say that some of the SQLs, right, that we have, some of the SQLs, if you have like now, you have now, say that you have now, you have now a RAND, right? RAND-like function, which are non-deterministic functions. Okay, these functions can create a problem in the DB, because when there is an insert which has happened in this DB, right, in the master DB, and you're trying to replicate with these function as part of your insert statement, right, or update statement, they are non-deterministic, and that would cause a problem in the follower, because the data that between these master and the follower, right, they will have a different data for these two columns, or something you have in procedure, and they may have a different data. So that is where and the other problem is the auto increment problem, which we spoke about in the GitHub problem, right? So when the master is having so non-deterministic functions are like auto increment. So because the master would have a different increment, and whereas the follower can have if it has an auto increment, then if that's the primary key, then it becomes a problem. So that's where we spoke about the GitHub problem that we told, right? One of the leader went down, but that primary auto increment primary key was already used by the leader. But when the one of the follower became as a leader, then it started having a problem. So in MySQL, right, lesson 5.1 was using this approach of replication with some intelligence. Okay, so the statement-based replication log only was used in MySQL below 5.1 version. But if there is a non-deterministic function in the statement, it uses the same value as from the leader. So now when you're trying to replicate a data log, right, when you're trying to create a function for this now ran and all, right, so you should make sure that the same value from the master is sent to the follower. So that is how you try avoiding this problem. So the VaultDB uses the statement replication and makes it a safe requirement of transaction by using a deterministic function for these functions. So I'm just giving you two examples, like now and ran, but there can be a number of functions in the SQL. So whenever you are building a system with all these in, you should keep all these in mind, saying that, yeah, what happens to a non-deterministic function? How are we going to handle those things? So the problem with the statement based replication, you come with all these non-deterministic function problems. Any question on this before I move on to logical based log replication? Okay, so I take that there's no question. So logical row-based log replication. So there are three different things, right? Like insert, delete, and update. So we will have different log formats what the database uses. Because of this, there is a decoupling of the storage engine, and there are also other benefits which we will see in the logical log based replication. So in an insert format replication, right, when you try to insert a insert statement, right, replication will contain exactly what has changed for an insert, and it will contain the value of all the new columns. So you will not send the entire insert statement, you will just send what has been changed as part of the insert statement. So there can be two things. One is you're trying to insert a new row, it's always going to be there. But if there is a case that you want to overwrite an existing column using an insert, then probably you send what values have changed, and the new values only you send. For a delete, it will contain what is the minimum information needed, like the primary key, to understand that this row has been deleted. If there is no primary key, then all the columns of the old value need to be sent. I think this is a little straightforward, right? So you just send, if there's a primary key, you basically use the primary key and you just send that. If there's no primary key, you send all the old values, so that on the follower side, it becomes very simple to delete that data. And the log, right, the size of the log that it is getting written, it is actually minimal. For an update, it will store what was the primary key and what are the new values in the new columns that needs to be updated. So MySQL, when configured with the log bin, uses logical row log algorithm to perform the replication in this fashion. The updates are easier because you do not have really a very strong coupling with the database. So because you know that okay, this for a delete, you just need primary key, or if you do not have a primary key, you just put that old value and you go, and it's not very closely tied up with the database engines and all. So the other benefit is that you can send this replication log not only to the follower but also to analytics pipeline, because you know that you're just sending only what has got changed. So you send it wherever you want, and if that data is already there, it's going to operate on top of that. If it is an insert, it's just going to insert that data. So So any questions on that?
I have a question over here. So this replication log, right? So there are multiple problems with the replication log based replication.
Yeah.
So for example, you are applying the replication on multiple slaves, maybe multiple different databases which are read only, and there is a problem in applying the log. So maybe somewhere in between it got broken up and you could not apply the full log. And then when you apply again, the insert rows will get inserted again, right?
Yeah, that's what I told, right? So that's where we spoke about all these asynchronous problems, right? And when you do asynchronous or synchronous problem, and then you have the follower going down or the leaders going down. So what if the leader goes down? All these problems is still there. This part I'm just trying to tell how things really happen behind the scene in a database, how they are actually done. There are different techniques I told, right? These problems are still there. You would run into those issues, like say that when you're trying to insert statement and this follower goes down, what will you do? So then what you do is then you follow these steps that because when you bring back the follower backup, right? Follower is back up. Then what you do is then the follower needs to send it to the leader or the master, saying that okay, this is where I have written my data. You start sending me all the data after that. Then it needs to do that update, and then it will again follow the same process. So that is always there. That is why I gave you a hint. What if the follower goes down? If the leader goes down, then there are a lot of other problems which comes into picture. So that is why you have this concept of single leader, multi-leader, and leaderless. Okay, so in which architecture are you trying to follow this one? Okay, so you need to link whether you're going to use log based using multi-leader or leaderless or a single leader. So it is up to us to design. But this log-based logical row-based log replication, right? So this is how it is going to work. But how are you going to use this to implement your replication architecture or system design?
Okay. All right.
So basically, you need to link all these with all these concepts that I spoke, with single leader, multi-leader, leaderless, and so there can be a synchronous replication or asynchronous replication. You can make these, right? These insert statement as a synchronized to the follower, or you can make it as an asynchronous approach. It is up to us to design that system, but how internally database works is what I'm trying to explain here.
All right.
Okay. Yeah, so now the write ahead log. So it uses LMS tree, log based segmenting segments, or a B tree, where logs are append only logs, and these logs are sent over the network to the follower. It builds a copy of the exact same data structure as found on the leader, like your Postgres or Oracle uses val, and it is at very low level. It knows which byte has changed, and it is very closely coupled to the storage engine. Okay, so say that you have an Oracle DB, and in the follower also you need to have an Oracle DB. So that is when you would be able to do the replication. That is because it's that engine, right? The val engine, right, knows exactly what byte has changed, and it only copies that. It only records that byte change. So when it sends to the follower, right, the same val engine has to be present so that it can read, it knows that, okay, this is the byte, then this is where it has to change in the database. So that's one problem that you will run in when you're trying to use a val engine, val-based replication. And this val engine is very tightly coupled with the database. And there is always a downtime to this. Say that you cannot run different versions. So you have version 1 here, you cannot run version 2 here. You should always have version 1 means you should always have version 1 only. So if you're trying to update here, do an upgrade, right? Say that you want to do an upgrade. You want to do an upgrade to version 3, then you should, you'll obviously have a downtime. You have no other option. You need to upgrade version 3 here also. So you do not have an option. So you still need to bring it down, then upgrade that. So then, so these are the problems when you use an write ahead log, and see how things are becoming complex when you start doing replication. So when you start taking this approach and you start putting into a single leader or multi-leader or leaderless, things become more complex.
So one query here, Manoj. So
Yeah.
when there is difference or incompatibility between the wall engines, right? Then
Yeah.
only you need the downtime. Otherwise, you can do the upgrade without downtimes, right?
Yeah, without the downtime. But obviously, you're going to get new versions and you're going to have security issues. Then you need to
Yeah.
upgrade the versions, right? So that's the real world problem, right? It's when you're not going to run the same version for next 10 years, right? So say Oracle Posters, which basically use that, they're going to release new version, and there can be security issues also, which security issues are taken very seriously in an enterprise organization, and you end up upgrading that, then obviously there's going to be a downtime. So so these problems are there. Then that is when your SRE engineers come. Then you have to have a lot of planning in place when you have these type of applications. Which one you're going to do a sequential upgrade? So yeah, these are very tricky. You need to have a lot of planning before you go directly and do upgrades. Yeah, let's move on to the last algorithm that we will speak today. Is the trigger. It uses an application code to run, but other three we saw comes from the database system itself, or third-party tools. You can use third-party tools to do it. Triggers when DB sees a change, right? The log is captured into a new table, which can then external process can read those changes. We as a developer should be very careful. They are complex. In some circumstances, we are more flexible. The flexibility is needed in some circumstances. Let's consider an example. If you want only replicate a set of the data, or you want to replicate from one kind of data set to another, or if you need conflict resolution logic, right? Then you may need to move replication up to the application layer, and you may need a batch processing to do the changes and all. So all these happen. So that's how the replication triggers actually work. Basically, if you have, I probably guess most of us would have worked on triggers, because you can create a material view in a different table by having the master table. If there is a change, then you directly do a trigger to that table. Or you can send it as a log to a follower DB also for replication. So that can also be done. But yeah, as I told in an example, saying that when you have you want only a subset of it to be processed, or you want to send it to a different external system, then you need to have an application code like a batch processing, where you would take the data then you do a lot of work on top of that data and send it across to different systems. So these things can be, it's more flexible when compared to others, but here a lot of developers would be involved in doing those changes. So this is all about replication log, how replication log is being done, and what are the problems that we would face when we are doing replication. So what are the architectures that we spoke, like single leader, multi-leader architecture, or leaderless architecture? All these come when you speak about replication. So if someone is very good in replication, right, is some interviewer is very good at understanding all these replication problems, right, suddenly you may be taken into that direction and grilled like anything. Yeah.
Correct.
So all these are something which we spoke about is more of replication related things. And so in the coming up weeks, right, I would be speaking about replication log. Replication lag. Replication lag is more of what really happens when there is a replication lag, and when someone is trying to read some data and there is a stale data, what really happens? What if in a scenario where someone sends the data and someone if two users are there, someone sends the first data, but the user B sees the data later than what he has already replied back. So there are a lot of replication lag issues which also come as part of the replication log. So that I would be speaking in the future. So if you still have any questions in this, yeah, I would like to answer those.
I'm good.
Yeah. If you need this document, I would send it as a PDF.
Yeah, I think that will be great. And would there any kind of recording also available?
Yeah, the recording I'll
Because I
share.
want to go back and check, those earlier topics probably a bit more.
Yeah, I probably guess if you need to go once again, because so these concept, right, I took it from Martin Klipman's book. So I read a couple of times to really understand the problem, what he's trying to tell, and things like. It's actually a very good book. I probably, as I've told many times, and I would like to repeat it, like designing a data in intensive application, and these diagrams, right, I took it from his book. Yeah, I would like to credit him.
Great.
Thank you. It was actually very beneficial session. I learned a lot. Thank you for that.
Yeah, I would recommend to go over once back this document so that you get refreshed again and again.
Sure.
Yeah, I will share these documents.
Sure, Manoj. I have one query around the materialized view and the trigger based replication.
Yeah.
So, materialized view, as I understand, are the views which could be used for writing data, and they can help in reducing the load from the master. Correct? Materialized view
No,
can.
no. So material view is like, say, for example, we had it in Bank of America. So there were when a customer is trying to log in, right?
Yeah.
So we had an account. We had an account table, but the account table is very complex when you have a lot of parent-child dependency relationship in the table, right? Because
Yeah.
of consistency which needs to be maintained.
Yeah.
What we did is the read should be very fast, but the write can happen in all these databases, all these tables.
Yeah.
Once all these tables happen correctly, then there is a trigger which writes the record into that account table.
Okay.
Okay. So when, say that I have created an account,
Yeah.
I'm trying to create an account. So it goes into all these tables. There are, say that around 10 tables it goes into.
Yeah.
And after that is completed, then it does a trigger and it writes a record into the account table. Say that after all these processes completed, tomorrow I try logging in, right? We will not go and read all that table because it has a lot of parent-child relationship, which will do a consistency check that it does all these checks and then only table returns back that if the data is there, then it does. But in a materialized view, is like a plain data. So you have to just have you can have a composite primary key in that table, and you will just go directly hit the table and pull out the data.
Yeah.
So it becomes like you basically use materialized view for reading purpose, not for writing purpose.
Okay. Sure. So for faster reading, you use
Yeah,
materialized view.
yeah. For faster reading,
And the writing happens in the real tables.
yeah.
But based on the trigger, these materialized views are automatically updated, or how is it?
Yeah, it is up to us how we create the triggers at the background.
Okay.
So it can be automated. So all your RDBMS databases, right, give you the flexibility of triggers. Basically,
Yes.
as part of your you can tell that when there is an insert, when there is a delete, when there is an update.
Yes.
The data capture happens begin the same. It does the basic this log, right? It does the same thing. It captures that event, and then there's another procedure which runs begin and picks that and does that update, or it can be a delete, or it can be a insert statement. Behind the scene, it does the same, but it does it within the same database.
Sure.
Well, the other thing is, yeah, so there was another thing that we did was that it was actually patternized, that approach. So it was like basically in 2010-11, I and my friend worked in a trigger process where we would capture the data on a regular interval, right? That data would be pulled. So there was an application code written, there was a small microservice written. It would continuously pull that data from a particular point. That say that for every 5 minutes we would read the table, capture what was the change, then we would do some merging of data, and then we had a queuing system, right? Based on that data, we would send it to different systems. Like if we would send it to fraud systems, we would send it to some alerting systems. All these were done. That was basically using your application code using triggers. So basically, in a table, we would capture the actual data that got changed. That's what I told, right? So say that this is your change logs, and this is your change log database. Here we would all the change data would be sent here. Then this application code would capture the data, process it, and it can be sent to a different data. You can send it to a different database or to an external system, or you can send it to queues, you can send it to topics. It's up to us how we design the system. So this, right, gives you a lot of flexibility. It gives you a lot of flexibility. It's even if you change the database, but the only if you have this right part as constant, and now you send that data here and you capture, this code doesn't need to change. You just need to work on this part and make sure that data is captured in the same way. This part you don't need to change, it will always be the same.
Sure.
Yeah, so basically writing batch processing and conflict resolution, right, is actually a complex. It's not so easy because you need to consider a lot of other things.
Yes.
What if the application goes down? What if there are duplicates? How do we handle all these? This comes into all these pictures.
Great. Awesome.
Yeah, thanks.
So wonderful presentation, and definitely looking forward for more sessions from you on various other topics.
Yeah,
As you
sure.
mentioned about
Yeah, I
the
would like to take the replication lag problem.
Yes.
After replication log, if you look into replication lag problem, then you would fully understand why there are systems that needs only consistency, why there are systems only taking direction of availability, then leaving consistency in a distributed world, why building a distributed system is more complex than having a monolithic application.
Great, great. Yes. So let me know whenever you want to take the session. We'll
Yeah.
schedule it. Perfect. And then also know one thing I wanted to discuss. I have know few people in the group who has conflicting meetings at 2:30, and even it starts from 1:30. So they have requested to start the session at 12:30. So will it be possible that we can change the timing and do it consistently at 12:30 so that more people can join, and these are few people from Middle East. So they want to have this rescheduled to 12:30 because of conflicts with other meetings.
I think we can stop the recording and
Yeah, yeah, sure. I'll do that.